Today we're going to be putting everything that we've been learning for the past few weeks all together. We're going to be able to find our slope and our y-intercept from a context table, graph, and equation. Okay, and we're going to be able to find it and create it basically on our own. Okay, so question 1 asks us, or rather tells us, that gourmet jelly beans cost $9 for 2 pounds. Part A wants us to complete the table. So the total cost is $9. I know that I just bought 2 pounds of jelly beans. Okay, to help me finish filling out this table, I need to find my unit rate. So if I know that it costs $9 for 2 pounds, it is going to cost $4.50 to buy 1 pound of jelly beans. So I'm going to use this information to help me finish filling out this table. So if I buy half of a pound, it is going to cost me $2.25. If I buy 3 pounds, it is going to cost me $13.50. Okay, now a quick little trick that I want to show you guys is that the nice thing about tables is that if we double it, so if I'm going from 2 pounds to 4 pounds, I can also double the total cost. So I can go $9 to $18, and I'm going to do that exact same thing with 8 pounds. So 4 pounds doubled is 8 pounds, $18 doubled is $36. Okay, now say I don't know how many pounds of jelly beans I have, but I do know how much it costs. I can use my 7th grade math skills and set up a handy dandy proportion, okay, like this. So if I know it costs $9 for 2 pounds of jelly beans, it's going to cost $27 for an undetermined amount. We're just going to say X. Now we're going to use our 7th grade math skills of cross multiplying. 9 times X is 9X equals 2 times 27 is 54. Okay, I'm going to get X all by itself, isolate my variable. I now know that it's going to be 6 pounds for $27. Okay, now the cool thing about tables is that if I buy 2 pounds of jelly beans and 4 pounds of jelly beans, it's going to be the same price as 6 pounds of jelly beans. So let me show you really quick. 2 pounds of jelly beans is $9. 4 pounds of jelly beans is $18. 2 plus 4 is 6. 9 plus 18 is 27. So if I don't know what 10 is going to be, but I do know how much 4 pounds costs and 6 pounds costs, I can just take how much 4 pounds costs, $18, and how much 6 pounds costs, $27. I can add those together and I get $45 for 10 pounds. I'm just going to use my neat little doubling trick, okay? And I'm going to find out that it costs $90 to buy 20 pounds of jelly beans. That's a lot of jelly beans. Okay, for this area right here, you can pick whatever number you want. It could be 11, it could be 15, it could be 19. Pick whichever one you want. Go ahead and fill out the table. Now let's go ahead and move on to graphing and labeling the relationship. All it wants us to do is to graph and label what is in this table. So, if you remember our sideways tables, the top is X and the bottom is Y. Okay, we always know this because money is always going to be Y. So I'm going to label my Y-axis as total cost. And I'm going to label my X-axis as pounds. And it's super important that I label what my units are going to be. Now I'm just going to take my unit rate, which happens to be $4.50, and I'm going to make those my units. So I'm just going to be labeling them, and maybe I'll jump up to 6, and 8 is 36, 45. Okay, now I can fill in the missing spots. 27 plus 450 is 3150. This is 4050. All right. Now for pounds, I'm just going to label each one of these solid black lines as 1 pound. So my units are going up by 1. Now, how I want you to graph this is I want you to pick 3 coordinate pairs, and I'm just going to pick 2, 4, and 6. Why not? Okay, so when I buy 2 pounds of jelly beans, it's going to cost $9. When I buy 4 pounds of jelly beans, it's going to cost $18. And when I buy 6 pounds of jelly beans, it is going to cost $27. Okay, I'm going to go ahead and draw and extend my line. Now, it wants me to, on part C, find the slope of the line. So what I'm going to do is I'm going to draw a triangle. It doesn't matter between which 2 points, just pick 2 points to draw your triangle. Now, this side length right here is going from 9 to 18 for a rise of 9. Okay, or an increase of 9. Now it's going from 2 down here to 4 down here for an increase of 2. Now remember that slope is the change in our y's over the change in our x's. So I went up 9 spaces and I went over 2. So the slope of my line is 9 over 2. I'm going to leave it as a fraction. Part D says to write the slope of the line as a rate of change that describes what the slope means in this context. That's basically just saying, hey, what does this mean? This means that we bought $9 worth of jelly beans and then it gave us 2 pounds. So for every $9 spent, we get 2 pounds of gourmet jelly beans. Oops. Okay. Now part E wants us to write an equation to find the cost for any amount of jelly beans. That's just fancy dancy talk for put it in slope-intercept form. Y equals mx plus b. Okay, but we have to figure out what our slope is and what our y-intercept is. Well, lucky for us, we already know what our slope is. It is 9/2. Okay, and we always mark our slope by putting an x next to it. Always. And b is our y-intercept, our starting point. Okay, where it crosses the y-axis. Oh, hey, look, it's a proportional relationship. It starts at 0. You could also write this as y equals 9/2 x. Either one of these will work. So part F, why is the data graphed only in the first quadrant? If you remember from 7th grade, we have 4 quadrants on our coordinate plane. We have quadrant 1, 2, 3, and 4. Okay, quadrant 1 is what is shown here in part B. Why is our data only graphed in this first quadrant? Well, we're not going to graph it in our third quadrant because it doesn't really make sense to pay money or to get money for giving away jelly beans, because we're not the business, right? Like, we're not getting money for giving away jelly beans. Maybe unless we sold the jelly beans to our friends, right? But this is just asking us what we're going to pay for buying jelly beans from the business. Okay, so for a positive number of pounds that we buy, so for every pound that we buy, we are paying $4.50. That is why. So if you want to, you can go ahead and pause the video if you haven't done already in class. Pause the video right here. Read through number 2, complete the table, graph and label the relationship, and then answer these 3 questions. Okay, if you've already done it in class, let's work on part 3, or question number 3. Okay, Mr. Irving and Mrs. Hendrickson pay babysitters differently. Part A says to examine the table. Describe the difference. Okay, so here we have the Irvings, here we have the Hendricksons. Okay, so it looks like the Irvings don't pay babysitters any money for babysitting 0 hours. Ooh, it looks like the Hendricksons pay their babysitters $4 at the very beginning of the shift, just for showing up. Okay, so let's describe our difference. So I don't care how you describe it, but you could say, Irving family starts at $0 paid. You could talk about how the Hendrickson family starts at $4 paid. Okay, you could also talk about, oh, hey, for every 1 hour that they work, they get paid $9 at the Irving house. So the Irving family pays $9 per hour. And it looks like the Henriksen family, this one's going to be a little trickier, right? Because it doesn't start from 0. So we are going to find the difference between 4 and 12. Looks like it increases by 8. And the difference between 0 and 1 is it increases by 1. Our slope, or our unit rate, is going to be 8 over 1. So the Henriksen family pays $8 per hour. Okay, so even though the Irving family starts paying at $0, you actually get paid more dollars an hour. Okay, so part B asks, are both relationships proportional? Remember, proportional means that it starts at 0, 0. Okay, so when x is 0, y is 0. So when our hours are 0, are both families start at 0? No, both families do not start at 0. So, nope. Ooh. Okay, just the Irving family. Okay. Part C says to graph and label the 2 pay rates, 2 different lines. Okay. I would pull out 2 different colors so that it's easier for us to see the difference. I'm going to go ahead and label my graph. I'm just going to do it orange again. So X and Y, remember X is going to be the hours and Y is going to be the amount paid. So we actually have 2 Y columns here, but the Y is still the same. It's the price, or the amount paid. And it is in dollars. And X is the hours babysat. Okay, so let's just start at 1 hour, 2, 3, 4, 5 hours. And the amount paid, let's start at, let's go up by $2. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, now I know that we won't actually get that far over, and the graph obviously exceeds the amount, but let's go ahead. So for 1 hour, let's pick a color for each family. Let's pick yellow for Irving. I'm just going to make a little key off to the side. And let's pick purple for the Henriksons. Oh, Hendrickson. Okay. So, Irving family. For 1 hour babysat, actually, let's go to our starting point. Our starting point is at 0, 0, so I'm going to put a little dot at 0, 0. For 1 hour babysat, we make $9, which is halfway between 8 and 10. And let's go to 3 hours babysat, we make 27. Oh, well, that's way off our chart. So as long as we have 2 dots, we should be good. We can go ahead and graph that. Okay, Henriksen family. Their starting point is $4. So I'm going to put a little dot right here. For 1 hour babysat, you make $12. Okay, I'm going to go ahead and draw this line. Okay. So now we see that over time, so the more hours I babysit, the more the Irving family pays. Actually, I'm going to draw my line. Just a little bit better. Okay, somewhere around there. So what is the slope of each line? Okay, remember, I can go ahead and I can draw my triangles. I'm going to draw my triangles below for the yellow one, just so it doesn't get in the way. And I'm going to draw my purple triangle above, just so it doesn't get away in the yellow triangle. Okay, so for Irving, the rise of my triangle is, so let's go from this point down here. So I start at 9 and I go down to 0, so I decrease by 9. And I'm going from 1 down to 0, so I decrease by 1. Negative 9 over negative 1 is just 9. Or $9 per hour. Okay, the Hendriksons. Purple. Okay, I'm going to start at this point. It really doesn't matter which point you start at, just as long as you make sure that the signs are indicative of what direction you go. So if I'm starting at 4 and I go up to 12, that means I have increased by 8. So increased by 8. And if I'm starting at 0 and I go over to 1, that means I've increased by 1. That means that my slope is 8, or $8 per hour. Okay. Part E says, write each slope as a rate of change to interpret its meaning. Easy peasy. For earrings, I make $9 an hour. And for the Henriksons, I make $8 an hour. So explain the different Y-intercepts. Okay, what is different about our y-intercepts, if you notice, one of them starts at 0. Okay, that means that you don't get paid for not working. And one of them says that you do get paid for not working. So in the first hour, before it even hits the hour mark, you've already made $4 just for showing up. Okay, so I want you to put it in your words, explain the different y-intercepts. Now I'm going to go ahead and go on to G. Is one babysitting job better than the other? Why or why not? In class, we did this with partners. Here, I want you to pause the video and I want you to think about which one is better, why or why not. Okay, and part H. Let's write an equation for each situation. Okay, we're going to write our equation in slope-intercept form, y equals mx plus b. So, we want our slope for the Irving family, which we found out was 9. Now, the Irving family starts at 0, so that is their equation. You could also write it as y equals 9x. The Hendrickson family, y equals, their slope is 8x, and their starting point is at a positive 4. So that is their equation. Okay, in class, we did these together. I'm just going to go ahead and go over them really quick. And let's pick blue. Blue's a nice color. So it says for each of the equations given below, make a table of values to help you graph the line. Okay, so it gives us an equation. It wants us to make a table and then graph those points on our coordinate plane. Okay, then it wants us to identify our slope and our y-intercept. It says circle the slope in your equation and put a star next to the y-intercept. Okay, so let's circle our slope, and our y-intercept is -2. So how do we put this in a table? Well, we know that when x equals 0, y is going to start at -2. Okay, now our slope just means that we go up 5 for every 1 on our x, okay? So each time we're going to go up by 5. So -2 plus 5 is 3. We can keep going up by 5. And we're going to use these points right here to help us graph. I'm going to quickly write my slope and my y-intercept. So my y-intercept is at -2. I'm going to put a little dot there. When x is 1, y is going to be 3. So I'm going to go over to the little 1, go up 1, 2, 3. I'm going to put a little dot there. When x is 2, y is going to be 8. Okay, that looks like as much as I can graph right now. I am going to go ahead and maybe if my technology will like me, I'm just going to go ahead and graph right here. There we go. Okay, let's go ahead and do that quickly for our next one. Let's circle our slope. Oh, hey, it's 3. Put a star next to our y-intercept. Hey, it's a +1. Okay, how do I put that in my table? Well, I know that when x is 0, y is going to be 1. That's my y-intercept. And it's going to go up by 3 each time. So this is going to be 4, 7, 10. Okay, I'm going to go ahead and graph it. My y-intercept is at 1. When x is at 1, y is going to be at 4. When x is at 2, y is going to be at 7. And it looks like I can even graph my third point. Okay. And if you have a ruler, you can just draw and extend your line. Now I don't have a ruler here, so I'm just going to try to make it as straight as possible. Okay, in class, I'm having you do this one on your own. And then here is our homework. It is 2.2E class activity. Okay, pay attention that it is 2.2E. All you have to do is just pick 3 scenarios to do. You do not have to do all 5. Pick 3 of them, staple them together, and then we'll turn it into our basket.